What I want to show you in this video is that there are a couple ways to get to an equation, and you know, first of all, that if you find when x is 0, you have your starting value, and if you look at any two consecutive levels and you find what it multiplies by, you're also finding the constant multiplier. So you know the two important things to make the equation for this table. So what I can do to work my way backwards to get when x is 0, I'd have to undo all this multiplying by 2 and divide by 2. So again, that 4 will fit in there. So I know my equation could be y equals 4 times 2 to the x. The problem is I don't really always want to go back and find the starting value. I don't want to find when x is equal to 0, because that's a lot of work and sometimes can be tedious. So another thing we can do instead is we can ask ourselves, how could we use this here in order to get to our equation? So one thing I could do is I could say that y is equal to 8 times 2 to the x. The thing is, though, in order for me to get back to my starting value, I'd have to divide by 2 once. So I can divide by 2. I could do the same thing here. I could say that y equals 16 times 2 to the x, and I'd have to divide by 2 once, twice. I'd have to divide by 2 to the second. I could just as easily say y equals 64 times 2 to the x, but I'd have to divide by 2 1, 2, 3, 4 times. Another way we can deal with this same situation is to say instead that I'm going to multiply, so I can switch my denominators if I want, and instead my equation could become y equals 8 times 2 to the x over 2. I'm going to put to the first here. And here we could say y equals 16 times 2 to the x over 2 to the second. Now, just as an aside, you have known this before, that something like 5 to the 4th over 5 to the 1st. If I do this in expanded form, I can prove it to myself. That's 5 to the 3rd. When I divide, I subtract exponents. So let's hop down here. I could take this same equation now, and when I divide, I subtract exponents. So this could also become y equals 8 times 2 to the x minus 1. Or this one here could become, this one over here could become y equals 16 times 2 to the x minus 2. Let me try this with a different pattern here, just so you can see what I'm talking about a little bit maybe more clearly. So 5, 6, 7, 8, and maybe this is, sorry. So let's say here 25, so I'm going to multiply every single time by 2.5, so I think this would be 62.5. So this is 2.5 is my constant multiplier. Again, I don't want to go back to when x is 0, so I can just say y equals 10 times 2.5 to the x. And I could divide it by 2.5. I'd have to divide it by 2.55 times. Or what I can do is I can say y equals 10 times 2.5 to the x minus 5. And I've taught students before who will say, well, this minus 5 makes sense because they were 5 away from 0, from the starting value. So see if any of those ways make more sense of the situation for you. And if for you right now want to concentrate on just writing something like this, that's totally fine, and we'll transition into these other approaches later on.